So what is tidal energy? Tidal energy is similar to hydropower. It's a blade that gets turned by moving water. But in hydropower, it goes through a penstock and then that turns the blade. But anyway, so tidal energy, so they are very big, and so the water current turns the blades, and then the blades turn the generator, and the generator will make electricity. So how does tidal energy work? Well, like I said before, but there are different designs of them. There's like the one you saw before, which are like wind turbines, but then over here they have like propellers or blades that are sideways, so they won't hurt the environment as much as the ones with the bigger blades do. Well, yeah, let me leave it. So here's a little video. I don't want to show all of it, but we can show the first probably minute or so. Is that okay?
Tidal energy, the world's most reliable energy source. Twice a day, and every day since the world began, the oceans produce powerful water currents and tidal movements that are so reliable they can be predicted years in advance. For centuries, mankind has sought to exploit this massive source of potential energy. In Roman times and the Middle Ages, mill wheels driven by flowing water were used extensively for grinding wheat into flour. Until recently, there has been little development in our ability to harness this huge resource of power. Today, the wonders of modern technology have allowed us to extract this huge potential of raw energy for the production of electricity without harming the environment. So why the focus on tidal energy? The world has an increasing insatiable appetite for power. Global warming is compelling us to move away from fossil fuel.
So further on, if you want to learn the whole video, I can show you the link, but we're trying not to waste our time here. So as we saw, renewable sources of energy is trying to push us away from fossil fuel since of global warming and stuff. Next one.
You have to put the arrow.
So here is a similar way of showing the example. Just click the arrow. So this is sort of related to this question, but I answered it already. So it's that they have their first tidal energy generator, and it doesn't look as good as the other ones as we saw in the picture, but it's because these little tubes over here, that's where the blades are getting all the energy from. So this is the first one, just off Sentosa Island. So if you want, you can try and look for it. It's you can probably tell by looking. It's probably nearby Gardens by the Bay, maybe. So it's around just off Sentosa at least. So that's right. So here's another video. You can probably watch a few, like a minute, because I have lots of videos on here. But so this is a little clue. So it's the first one in the world. Is it looks like a nice water technology, and it works 20 hours a day, which can make 1.2 megawatts and power 1,500 homes in Ireland. And this is in Northern Ireland, in a nice lake that has nice currents. And over here in the video it says that there are 4, but there's actually 1. But it's just to show many of them working at the same time. So, yeah. Yeah, you can skip this part.
In times of growing energy demand,
That should be the area.
Whoa.
Yeah, it's slowly. turn it back a little bit more? There. There.
And climate change debate. The development of new technologies for sustainable power generation is becoming ever more important.
Try not to turn too much.
Concept upside down and take it below the surface of the seas, where the tides provide an infinite supply of clean energy. Just off the Irish coast, the world's first commercial-scale tidal turbine was at work. The power of the ocean and the turbine's advanced technology guarantee a much more predictable energy output than other renewables. Twin 60-meter rotors and horizontal axis to capture kinetic flow. 180-degree pitch control to generate power from flood and ebb tide, providing a predictable runtime up to 20 hours per day. The turbines are permanently connected to the power grid and produce 1.2 megawatts of clean energy that powers 1,500 Irish homes. With no primary cost.
So as we saw, that just off the Irish coast they have their first one in the world, and so probably some of it were. Did you understand some of the parts where they were under the water, where they showed the blades? Some of you might not understand, but the ones who don't. So the blades can turn around 180 degrees. So even though the tidal's going the opposite direction, it can still pick up the tidal current. Next slide. So you can click the arrow again. So moon tidal is basically like the moon. I'm not really sure how it actually does it, but the gravity pulls the earth and pulls it towards the water. And the water moves up into the light bubble, into the slide. And then, yeah, this is what Jasmine's going to say, but Jasmine's not here. So basically, in a very cool and fascinating way, the moon can make waves by pulling water. Yeah, that's the fancy part. Sun tidal. So basically, the sun does the same thing, except it pulls it from the moon only pulls it from one side, the sun in a way pulls it from both sides. So it's very similar in a way. You can put the next slide. There's another example. Tidal energy cycle. Click next. Oh yeah, you missed one. Like, yeah. So this is a tidal, a measurement in some countries. So once it reaches 12 o'clock, so the tides are in a high level, and then once it reaches 600 hours, it goes a little bit lower, then it goes higher after 1,200 hours, and then 1,800 hours. And then it goes down and then it goes up. So that's like a pattern of the tides. So the positives and negatives. Positives is tides move throughout the day, which provides a stream of electricity by the blades turning the water. And also, no material resources are used in the tidal power from the earth, making it truly renewable from power form. Tidal power turbines are fully or nearly completely submerged in water well offshore. It reduces the damaging of water views. That has been ascertained. Sorry, Jasmine wrote this. I didn't read it. But with offshore wind turbines. Negatives. Sea life / divers could be hurt by the turbine's blades in the open sea. What about you write it down? If I write it down because so also here, and another negative is strong ocean storms and salt water can damage the devices, which could raise the cost of construction to increase of the breakdowns. They can explode in the ocean and cause a tsunami. So what I mean that, so when an explosion, it usually happens in a big bubble. Once it pops, like once it reaches the top, it won't be a very big tsunami. But anyway, so it's like, so the bubble pops and then that pushes all the water into different sides. But that's not, it's an opinion. That may be true, but just to try to get info. And they can start a whirlpool if they go too fast. So the current goes too fast, and when the blades go too fast, that sort of like sucks in the water, and then that sort of starts a little whirlpool. Hopefully not too big. Here's one example of a negative. The idea was turning the turbines upside down, wind turbines upside down, so they can get the water energy. And it was a success, but it wasn't perfect though. After this slide is the reason why it isn't perfect. Yeah, this is sort of big. So this is example. You could probably play a little bit of it.
Probably half of a minute.
That's a minute. Oh. Yeah, I don't always have it. For some reason.
But what happened to
What? You just click the thing.
No, we have to watch that weird.
No, we don't have
There are
to.
surprising new details about what happened to Nova Scotia Power's Tidal test turbine in the Bay of Fundy. Today we learned that it took just 20 days for powerful currents to destroy all of the turbine's rotor blades. All Winners reports.
8 months after being pulled from the water, today the test turbine is at a metal fabrication yard in Dartmouth. While across the harbor at a Tidal Energy conference, an executive from the company that built the turbine gave new details about what went wrong.
The actual velocity seen at the site resulted in forces that were 2.5 times greater than the turbine was originally designed for.
Brendan Core revealing that within 3 weeks of its deployment on the floor of the Miner's Passage, all 12 rotor blades were completely destroyed.
Preliminary indications are that we would not be able to return that particular turbine to the rotor, which would mean we engage in the design and supply of the second turbine.
The company says the force
Keep it going, okay?
currents, not a collision with underwater ice or debris, destroyed the blades. Open Hydro and its partner Nova Scotia Power are one of 4 consortiums trying to turn the tides into electricity under extreme conditions.
It's like a force for a hurricane goes through there 4 times a day. And so it's like saying to these people, well, build us a wind turbine, but you can only do it during a hurricane.
Nova Scotia's Tidal Energy Development Program is a $110 million project, still experimental. This result viewed under that perspective.
It's like they broke a drill bit and discovered that we have a reservoir that's twice as large as anybody thought it was.
Open Hydro is bearing the cost of the second turbine, which it will deploy next year, when 2 other prototypes are also expected in the turbulent waters of the Miner's Passage, an area now being described as the Mount Everest of tides. All of this, CBC News, Halifax.
There are surprising.
Okay, so like we learned here, that only took 20 days for a tidal generator with I think it was 12 blades or something. Yeah. Got destroyed by the tidal generator was specifically made for a certain amount, and then got destroyed is because the currents of the water were 2.5 times greater than expected. So you can move on. So fossil and are likely to do floods and droughts. Scientists estimate that oil will run out during the 2025 and 2070. Next slide. Bibliography question. So here's our bibliography.
YouTube.com.
Yeah, what? YouTube. We didn't think of YouTube. Okay, YouTube next. Thank you. Next slide. Next again. Good. Next again. Next again. Thank you.
And now
There's 20 bit. You know how like wind turbines, they've got a gearbox to control how fast they go. Don't with tidal like blades, don't they have a generator and then to the speed?
Maybe. I haven't gone that deep into it, but I've seen a few diagrams, but none of them said a gearbox was in it. So some of them, like the one that we saw in the big video, that I think $1.2 million project. Oh yeah, $1 billion project. So that's how much they could cost. Yes, Madeline?
do all tidal turbines look the same?
No, they don't actually. Some of them look like this. Some of them have 12 rotor blades. Some of them have 3, and some of them have 4, and some of them have 2. There's many different shapes and sizes. That's just an example of how tall they could be. One further up, and then those ones, and then further up, yeah, those ones. And also, I want to move on. There's this really interesting part where when they tested it, can you like try and play and go a little bit forward into that? This one, yeah. There's a very interesting part, but it was in the more than 1 minute. So just click it. Yeah, sometimes that happens. Ah, there, click play. So just skip up to around here.
Tidal energy is free. No
That's how-
expensive fuel is required.
Move a little more forward. Move forward a little bit more. I think around.
Whilst most companies have been
another
working on new versions
That's
of
another example.
wheel or windmill technology, Tidal Energy took a different approach, working on turbines mounted in shrouds, also known as
Okay,
venturis,
around
to
here,
improve.
yes.
Griffith University in Australia and industry experts have independently tested the Davidson Hill Venturi turbine, declaring it the most efficient water to prove the scalability of the design, allowing Tidal to 100 metres
So
squared.
2.5 meters square to 100 meters square. A little bit more back. Yeah. Play.
To Venturi turbines in sizes from 2.25 metres squared to 100 metres squared, capable of generating power from a few kilowatts to megawatts.
Okay.
The Davidson Hill
Yeah. So that's it spinning. That's it stopping. That's it spinning. So you can tell it actually spins like a real turbine. What is the report? So it works. If I add a generator to it, it will really work. So, if one, I can give you some time, like to look around it. You want some time?
Oh, you can give us 5 minutes.
You use 5 minutes left till break's over.
3 minutes.
All right,
Okay,
thank you
so-
very much, Oliver.